I am blue.
Interrupt much? Jeez. I do have one request from homework. So let's look at this problem and then we'll discuss, well, I mean, just before we get into this then, remember tomorrow's the quiz. It's, so it's been moved. So it's 5, 3, 5, 4, 5, 5. And let me show you something. Let's see. So go into Canvas and you go to modules and you scroll down, 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 down. There, Unit 5. This is the practice sheet and this is the answers to the practice sheet. It's crazy. And it was done early on Saturday, which was a bad idea. I'm a little, well, you're used to me being kind of loopy. You're my last class of the day. And at that point, I am definitely loopy. So this is just normal me then. So you can watch that. You don't have to. You can do this. You don't have to. It's just supposed to help you get ready for that quiz tomorrow. And let me see. I have a question from, oh shit, I thought I had the book open. Dadgummit, past Jeff. All right, here we go. I have a question from section 5.3. Oh yeah, let me see. Can you shoot me an email? Say, can you check the due dates? Could somebody do that for me? I might want to check the due dates, yeah. You can always shoot me an email saying, hey man, your due date's right. And I'll say, yeah, too bad, or I'll change them. Just stay on me about that. All right, let me share this book. Let me see, what was it, 5? Oh, shit, I lost my chat. Section 5.3. Oh, I got another question too. 5.3, number 18. Okay, let's see. Do. 5.3. Number 18. There we go. All right, let's see what the instructions are. Find the extra t-intercepts. All right, so number 18. Ooh, yeah, 18 is yummy. It's always creepy when I say that. I'm sorry. So yummy. What is it about this that tells me it's possibly factorable directly? Anybody?
The middle term has half of the exponent of the first term.
I love it. The middle exponent is half of the first exponent. And we've discussed this before. It makes sense because if I'm going to go make little parentheses, the first thing I do is cut the first guy in half. And the first guy, the two parts, are what go into making the middle dude. So the middle power must be half the first power for it to be like a trinomial situation. And this will factor. And then you'll get a couple of cubes, a difference and a sum of cubes, and then you just have to factor those two. Sounds exciting, I know. Does that help for whoever asked that question? Okay, so then the next question, and if you have any follow-up questions about whatever I look at, feel free to ask away. 5.5, number 39. Oh, man. Let me see. What was it? 39, right? How do I keep closing my chat? That is really not smart. Put you over there. Oh, yeah, look at that bad boy. What are we supposed to do? Why is that poor little exponent so tiny? That's kind of mean. All right, book. Stop. Stop. I'm sorry. I talk shit about you, book. All right. So what's it say to do? Use the rational zero theorem to find the real solutions to each equation. Okay. Yeah, so this one, you got to start off. It doesn't tell you to do this, but you're going to want to make a list of possible rational zeros. Are you guys with me? So you're going to have to take the factors of 6 over the factors of 8. One nice thing is they share factors, so it's going to, some of the possibilities will be repeated, so it's not going to be as long of a list. You could also possibly notice, I forget when we talk about Descartes, was it 5, 6? No, it was 5, 5. Yeah, so you can even use, look, why would Descartes help you out here? Why is Descartes actually useful on this problem? Can you guys see that problem? Oh, shit. There he is. Anybody? Yes, there we go. They're all positive, so therefore there are how many whats? No positive solutions, kick ass. So then your list gets cut in half. And then you just got to attack it. You just got to try stuff and see what works. You guys, does that make sense? Who asked that question? Person that asked the question, is that all right? No? Yes, okay. And if it's not okay, just say no, it's fine. Then I got number 30. And the same idea here. No, wait, what is the, so just, all right, yeah. So again, you can make a list of possible rational zeros. I'm guessing you probably did that. Did you just not get anything to work, or? Okay. Oh, somebody else asked the same question. I'm very curious about this now. We did get something. I think we did this question, and we did get something to work. I can't remember now.
Yeah, we got negative 2/3 to work, and then you get an irrational.
Yeah, that's fine.
Zero after.
Yeah, that's fine. Yeah. Because it's a third power, I only have to use synthetic division to get it down to a second power, and then I've got other methods to deal with, right? And they just want real solutions, so which means if you have an irrational set of solutions, then you better list those too. But then you can just use quadratic formula on what's left, right? If it's not factorable. So that's beautiful. You just need to find one to bring it down to a second degree. And then you can attack that with all kinds of stuff. All right. How are we feeling out there? Is that all right? Okay. How's everybody else doing? If you're somebody who's very behind on homework, or maybe not really doing much of the homework, that's bad, okay? You're not one of these people that have actual questions because you're not generating questions for yourself. Here we go. I'm not trying to tease more questions out of you. I'm just saying. Sometimes I'm worried that that's happening if I don't get a lot of questions. So now I got one from 5-4. Number 72. I got a question. How many questions will the quiz have? I don't know. It's tomorrow, right? I got to make that thing. Probably going to make it tomorrow morning. I don't know. I have a feeling it's going to be somewhere between 5 and 10 total questions, counting A through J or whatever, right? I always hate when a teacher says there's 4 questions and then they're all A through J. It's like, what the shit? All right, 72. Oh, somebody left. Shit, I'm sorry. Oh yeah, this is a good one. This is a good one. So what you need to know is, what is the formula for the volume of a cylinder? Does anyone know? The volume of the cylinder is such a...
Squared.
Yeah, yeah. You got it? That's right.
Pi r squared times height.
Yes, exactly. And here's why this is so beautiful. It makes so much sense. So all a cylinder is, oh shit. Give me a second, everybody. Old man with technology. Do 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 do. Do 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 do. I will learn someday. Okay. And then I got to do this. Okay. So what's beautiful about the equation for the volume of the cylinder is, imagine a cylinder is basically a stack of, well, I would say records, and then I would say CDs, and then everybody's still like, what are you talking about? I stream my music. What the shit's a CD? So, and then I would say pennies, but there's a shortage of those, so you guys might not know what those are either. So it's a bunch of discs that are stacked. So if I knew the area of the circular shape, how many of those are stacked? H of them. So the area of the base is pi r squared, and then times H of them stacked up. So the formula for the volume of a cylinder makes so much freaking sense. It's scary. Hopefully, I don't know if you guys agree. So what the hell does that do for me? So what goes in, so ignore the pi. Some of you guys are having too much, I don't care about pi, ignore it. What is this made of? This is made of r squared times h. And we know the radius is 2x plus 5. All right, how are we doing? How's everybody doing? Is that all right? So what do I do with this knowledge that this is made up of 2x plus 5 squared times something? I'm trying to figure out what that something is. What could I do with this together with this? I got a chat. Let's see. Yes, sure. And in fact, you can synthetically divide. You just have to do it how many times? Oh, there's a chat. The chat probably says twice.
Twice.
Yes, I like it. Why do I keep closing you? Because you're annoying, little chat box. So the real issue is when you go to synthetically divide by this twice, what are you going to put in the penalty box? That shouldn't be a problem. There you go. That's not the problem. The problem is when you divide by this, you aren't looking at this. You are looking at this. And that's not what this is it? So the book has one way to take care of it, and I always just hated doing that. I just know that when I do this, the answer I'm going to get is twice what it's supposed to be. That's all. So when I get the answer, I'm just going to cut everything here in half. And then what am I going to do? I'm going to freaking do it again because there's two of them, right? Is that all right? You guys get that idea? It's because I knew what goes into the formula and I know what the output was. So I know that this piece is constructed from two of these times some other thing. So if I divide these two out, what I'm left with, of course, must be the h, must be the height. Okay, maybe. So that one is a really good problem. I really appreciate that problem because it's got a couple things happening in it. All right, let me see. Did I miss anything? Yes, I did. Or is that one this one? Yeah, that one's this one. So I got everybody's question. Yes, cool. Could you repeat what you do after you divide twice? Sure. Well, after you divide twice, you're done. Because after you divide twice, what's left is h. I have a question. I'm not sure if I really understand. For the test tomorrow, are we going to have enough time for the trial and error and graphing? Oh, I see what you mean. So what I normally do on a quiz that involves rational zeros and all that stuff is I try to make you do the work that will decrease the number of possible answers as long as you understand what to look for. Are you guys with me? Just like we used Descartes a minute ago to cut our list in half. Does that make sense? So I might ask you to show that this is a lower bound and show that this is an upper bound, and that automatically cuts your list down. So it's not all trial and error. I kind of help you cut some stuff down as long as you know how to interpret what you get. Does that make sense? Okay. Somebody is telling me that they are a dumbass. That's interesting. Oh, I don't know. You're fine. You're fine. It's the same kind of problem, so I don't care. All right. As long as you show me the work, it's all good. All right. Anything else? Okay. All right. I like it. And you know, anytime, well, we'll talk more about the quiz tomorrow, but just like before, if there's a technical issue or you just get in touch with me. And then I can work with somebody individually. If the technical issue is major, then I can have you take a different version of the quiz or something. Anyway, so we can work something out. Let me see. All right, let's see. 57 on 5-5. Somebody has realized if they just keep asking questions, I can't do any new stuff. All right, I think this might be the last question. See, I have control, so 57 on 5-5. Wait a minute. I'm not sure I understand that question. I really need to. Let's say we use different numbers and we do it in our head. Do we need to show work? What does that mean? Oh, I know what you mean. So you do like some synthetic division work in your head and you can see that it's not going to work. Is that what you mean? Person? Yes. Okay. Yeah. Yeah. You might want to at least jot a note down saying, I tried these in my head and I saw it wasn't going to work or something. I need to see your thought process. So that is part of your thought process. So as long as you can capture that, that's probably okay. But I understand about saving time. And I even said a lot of times you can kind of do it in your head until it's just never going to work, right? On the third one, you got 487 million. You're like, well, that's never going to work. Yeah. So it's a hard balancing act for me because I need to see work, but I keep talking about the more you understand those you got to do. So at least jot a little note saying, I did 3 and 4 in my head and I could see it wasn't going to go anywhere. So then I tried this and it went somewhere. So here it is written out or something. Does that make sense? Maybe I'm going to go on like it does because I'm not getting anything back.
It's good sometimes to keep going because then you can tell if you're going to get all positives or an alternating sign so you can cut out your list, right?
That's another good point. I mean, if you're doing this in your head, like Jason is saying, you might, and then you stop before you get fully done, you might miss out on it being a lower bound. Because maybe you went all the way, it would be alternating signs, right? Yeah, so that's a good point. Thanks, Jason. Let me see, what was I going to do? 57, here we go. All right. So list all possible rational zeros. This one, right? Let me see, yeah, 5755. So how do I develop the list of all the possible rational zeros? What do I look at? So this one. Yeah. So you look at, on the top, you would put plus or minus factors of last term. And on the bottom, you put the factors of last term coefficient, I should say. I really should say constant term. On the bottom, I'm going to put factors of first coefficient, assuming it's in descending order. So that's really just saying plus or minus factors of this over the factors of that, and then you make all the possible combinations. So I mean, relatively, this is going to be a short list. Yeah. Okay, how's that sound? Let's see, who asked me that question? Oh, it was you. Okay. All right, I like it. What was I about to say? If I had a problem, let me see if you guys get why I was careful about how I said this. If I had to do this, oh God, Jeff, why? Why? If I had to do this, how would you make the list of possible rational zeros? There's sort of it's sort of a trick question. Do you need any help to get one factor done? See somebody typing.
You factor out an x.
You can take an x out. So that's why I meant if the last term is not constant, that means you can take an x out, right? Because this is going to be polynomial, so that means everything's got an x in it. I haven't seen a problem like that. So then you just blah, 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 blah. And then your last term will be 1. And your first term is 1. Well, that kicks out a lot of ass. Maybe. Probably doesn't work because I just made all this shit up. But that's the idea, right? So that's why you keep seeing constants at the end. Otherwise, one factor is real easy, and you got to know to get it out of the way. Okay. All right. That's enough. Let me see. I am going to clear this. Go away now. Okay. So we got through, yes, you can use calculators on the quiz. And just a reminder, do not graph something before you plot it. On the homework, I'm seeing way too many things that obviously came out of the calculator. You are incapable of doing the work yourself if you've already seen the graph, because there are going to be things that you should never know. We don't know enough yet to be able to identify certain things about the graph by hand. So there are certain things I look for on the graph that tells me, oh, well, yeah, they just looked in the freaking calculator. I don't want that shit. So I want your graphs to be a little ugly, right? And also, guys, let me see. Let me try. I never do this. Let me share just a whiteboard. All right. Oh shit, it's on the wrong screen. What are you doing? All right, I can't do that. Dadgummit. All right, let me just share the book then, and then use some space on it. So I guess I got some space over here. So, Jeff, you got to do so many levels of shit to go through. Okay. I will never see a polynomial do something like this. That makes no sense. 0 sense is made by that. It will, at the ends, it will always curve to infinity. It will always curve to infinity. It will always curve to infinity. In the middle, it could do wobbly shit. But when the x gets really big, so this is really why end behavior works. When the x is 18 trillion, 18 trillion squared is nothing compared to 18 trillion cubed. You guys with me? So this shit is basically nothing. When x gets really big, negative or positive, this guy dominates. So therefore, it's going to look like a cubic at the ends. When x is smaller, this shit has more say. So in the middle, that's why it's wobbly in the middle. But at the ends, this dude dominates. This basically does nothing. Does that make sense? So be very careful. Nothing about your, I'm seeing a few people doing stuff like this. Okay, that is definitely not good. There's no lightning strike polynomials. There's no linear component. Don't say that's a linear component because you got this other shit, right? So there's not going to be any linearization. When it's going through a first degree factor, it could look linear for a little tiny bit, but it never is. It's always curving. There's always some curve to it. Is that all right? I mean, not too many people are doing that, but just to make sure that doesn't happen anymore. Okay. All right, let me clear all that. Pop. Okay, so I didn't get, did anybody ask me a question from 5, 6? I think nobody's gotten into that yet. If our max and min are off, it's okay because you don't want them exact. Oh, Unless they say use the calculator to find the max or the min. Otherwise, you're exactly right. So somebody asked me if our max and min is off, is that okay? And I'm like, in fact, I almost desperately want them to be completely wrong. So it's a situation where we know it's here, and we know it's here, and we know it's there, and we know it turns here. I don't have a clue if the max is here, if the max is over there. So the best thing I could do is assume it's there, right? So if I see something like this happening, and that's correct, all right, that came out of the calculator. That's bullshit. But if you do this in your calculator first, this is going to stick in your head. And you're going to think, I better make it look like that because that's the right answer. But you shouldn't know that based on what we know to do by hand. Does anybody not understand what I'm saying?
I get what you're saying, but I also remember seeing somewhere in there where you can test some of the numbers on the x-axis to kind of estimate the max and mins, so you don't have to really look at a calculator.
To give yourself a little more, a little more stuff to work with, and we've done this in this class. Or this might not be the best example of this. Let me make this a little bit freakier. Oh shit, well, that's really freaky. All right, so there's a problem sort of like this in the homework. So it obviously can't just like, oh. So I would put, if you're way the shit out there, I would put what is f of -3 just to see where it is here. I'll bet you anything that's up there, that makes more sense for it to climb and then come down through here like this, right? But if I don't see the work and I just see you doing this and there's no point up here and it matches what the calculator says, all right, that wasn't you, that was the calculator. So there is not a damn thing wrong with doing a couple of test points in between these big ass spaces just to see what the shit's going on, especially when you get something crazy like that. So yes, that's a good point. And we did that a few times where we could do some test points. All right, somebody's chatting at me. Oh, okay. So now I got a question from 5-6. So yeah, so remember the quiz tomorrow is up to 5-5. So now I'm trying to move on to see if anybody has anything from 5-6. Somebody does. I'm going to clear this thing. Sorry, little dude. All right. You got to go away. I'm sorry. 5-6, number 51. I have zoomed in. All right. Yeah, okay, look at this. This is awesome. Write an equation for a rational function with given characteristics. All right, so vertical asymptotes at 5 and -5. So right there, what do you know about this rational function that must be true just because of these? Where do vertical asymptotes come from?
The zeros of the denominator.
Yes, cool. So therefore, what's going to be down here?
X plus 5, X minus 5.
All right, X plus 5 for this and X minus 5 for that. I like it. Now this thing we're going to have to be a little careful about, but I'll show you how that's not too bad. So what are these going to do? X-intercepts. They're almost exactly like these guys, right? Why am I doing this whole problem? How do you make this guy become 0? Well, it makes the top 0, so therefore that's going to do on the top much the same thing that did for me on the bottom. Maybe. And then to make the y-intercept work, you're just going to, a lot like we had earlier, you're just going to have a multiplier that you got to figure out. Yes. A lot of you guys were doing that with the straight up polynomial ones, right? You had something like this and you knew that at 0 it was supposed to be something, so you could actually plug shit in and figure out what A is. So you could do the same thing here. You know that the y-intercept is supposed to be 0, 4, right? So you got this little adjustment view that you can figure out. You can figure out what the y-intercept is going to be here, and then what number has to go there to make it become 4. That's the way I would do it anyways. There's a longer, weirder way to do it, but that is, I like the letter A for this because it's an adjustment. Does that make sense? So if I got, you know, if I had a problem like this, and I got this far, and they told me that the, oh my God, Jeff. Oh well. If they told me that the y-intercept is supposed to be 4 over 21, right? Somebody is, I'm getting an obscene phone call. What's happening out there? I don't even know how to mute people when I'm like this. Oh, is everybody with me so far? So like if that was the y-intercept, well, I would put a little a there, and what do I get when I put 0 in? I get -2 over -21. So then what would a have to be to make it 4 over 21?
-2.
-2, done. Next, thank you. Right? That's the right way to look at those a's, those adjustments. Figure out what it would be if it was 1, and then say, well, what's it got to be to actually make it match what it's supposed to be? Is that all right? So I like these kind of problems. These are backwards problems. You create the function that matches with these observations. And if you can do it backwards and forwards, then you know the shit. Any more questions about that one? I'm not getting an affirmative from the person that asked the question. Is there a follow-up question? Is it, did I do the right problem? I never know. Are you out there still? Okay, moving on. Oh, okay. All right, all right, all right. Gotcha. All right, so let me clear all that chicken scratch. So we finished shit and a half. There we go. We finished section 5.6, but it really does take just getting into it and getting some practice. So let's do a real quick one. Well, let's see how real quick this is going to be. Yeah, let's do 46. Is 46 weird? No. Uh-oh, shit. Somebody's chatting at me. 46 is a little weird. I'm sorry. I did erase it. Yeah. I didn't want to go too far because I didn't want to do the whole problem for you, but that looks like what it would be from what I remember. Yes. Okay. So let's do, real quick, why is 46 a little bit weird? It's going to lose some information. It's not going to be as interesting at the same time as it's weird. Does anybody see why this might be weird? How do you factor the top? The bottom, I'm going to assume we know. How do you factor the top?
3x plus 2.
Yeah, x minus 3, x plus 2. So what does that mean? What are the vertical asymptotes? Or is that a trick question the way I said that?
Isn't it just +2?
Yeah, because these would cancel, but x can't be -2. So the only vertical asymptote would be at 2. What's going to happen at -2?
Open circle.
Open circle. I like it. I like it a lot. So then, my poor little 3, dude. So that's your vertical asymptote. What's the horizontal asymptote going to be? What situation am I in?
Is it 0, 0, or 0?
No.
It should be 1 because they're the same, right?
Y equals 1. I like it because they're the same degree. So if you have the same degree top and bottom, highest degree, it's the ratio of the coefficients. Let me stop for a minute. Is everybody with me? And then what are your x-intercepts? or x-intercept?
X equals 2 comma 0 and negative 2 0.
Well, this is a 3, sorry. My poor little 3.
Oh, 3? Okay, yeah. 3 comma
0,
0.
but not negative 2 0 because this cancels. X can't be negative 2.
Oh, okay, yeah. So 2 comma 0.
I like it. 3 comma 0. All right. I can't remember if they asked me to do anything else, but this should be enough information. What's the y-intercept?
Would it be 3 over 2?
When you put a 0 in, you get 3 over 2. 10, 10. Okay. So that is plenty enough information. Let me put a couple of important things down here. So there's 3, 0. Let's see. We know, now here's the weird thing. You guys know how to handle this situation. I know the open circle goes at x equal negative 2, but negative 2 comma what? Where's that open circle going to go? How do you figure that out?
Would it be 0?
No. I think I know where that came from, but yeah, we can do that. We'll do that next person. These cancel. So I really want this to make sense. What's the only value of x that this does not work for? Negative 2. So what I'm going to do is I'm going to put negative 2 in here the same way we did with piecewise functions. Piecewise functions work the way they do. I can put a value in that I'm not allowed to because the function is going to act close to that. It's going to act like it wants to go to where that value wants to have the output. I can't put that in a more grammatically correct way right now without.
So it would be 5 over 4?
Yes. So this, if this wasn't here, if this actually had never been here, wouldn't negative 2 give me negative 5 over, well, yeah, 5/4 because the negatives cancel. I'm with you. You guys see that? That's a better way to say all that gibberish I just said. If this had never been here, negative 2 would have been negative 5 over negative 4, so 5/4. It would have went straight through there, no problem. But since this was here, I'm going to put an open circle at this point instead. All right, so it looks like my y-axis scale, we have some tiny little things happening there. Where's my, yeah, vertical asymptote is at 2. Pretend like that's a straight wall, poor little thing. This is one of the designs that was scrapped. Anyway. So now if I make my y-axis kind of big, I think, let's say, big steps, 1, 2, 3. Jeff, can't really do it. So now I can put, let me stop for a minute. Is everybody with me? So I see that open circle is going to be at a 5/4 output. My y-intercept is at a 3/2 output. So it doesn't look like I have to make giant steps here. So now I can put my y-intercept. I can put my open circle is at negative 2, 5/4. My horizontal asymptote is at y equals 1. Look how nice that is. And again, so how many, let me ask this, let me see how many people picked up on this. How many major regions do I have to worry about? I don't know if that makes sense. 2, there's only 2. Yeah, the vertical walls control my, so I worry about this side, and this side's basically defined for me. Do you guys see that? Just plotting the shit I know. Oh, this is supposed to be an open circle, sorry. So it's gonna, it looks like it's gonna be almost exponential here in a way, which is our next topic actually. And then over here, this is obviously gonna be like that. Now, it should be more like this, but oh well. Right, this is why you want to do stuff in pencil. It's kind of hard to do digital pencil, but oh well. And then you can check it on the calculator, and you only change something if you realize something on the calculator tells you you made a mistake over here, right? And then you don't change anything really major on your problem. I don't know how to explain that. You just got to be really careful about making it look too much like the calculator. Okay. And by the way, real quick, does somebody remember, I don't know if this is pushing it a little bit. Does anyone remember how to tell if it's going to cross its asymptote? If I take the function, which is now this basically everywhere.
Set it equal to the asymptote.
Yes, and set it equal to the asymptote. So if I take the outputs of the function and I set it equal to the particular output I'm interested in, look what happens. That looks interesting. So I get 2x equals 5. So x equals 5 halves. So at 5 halves, really, that's weird. That doesn't make any sense.
Because you set it equal to a -1 instead of a +1.
Oh, why did I do that? Thank you. That is so weird. So yeah, there's not going to be, so now there won't be any solution there. That, I'm really worried about myself. Where'd the -1 come from? All right, guys. Yeah, I don't know why I did that. So now when I do that, there's going to be no solution because the x is canceled. So there is nowhere that it crosses. I like it. Okay. So that was a good problem. I like it. So somebody asked, can we do one where the degrees are not the same? This is really, let me see, not the best selection here, is it? Can you guys see these two problems? Can somebody figure out how to get the y? I'm sorry, the horizontal asymptote? What's the degree on the top on this one?
It's x cubed, right?
Yeah, x cubed, and then on the bottom it's also going to be x squared x cubed. So that's, and the coefficients are 1 and 1, so that's going to be y equals 1. Ooh. And then here, the same thing, isn't it? That's annoying. That's boring. So the only ones that have different powers are these two. And what kind of asymptotes are we going to be dealing with there? Not horizontal, but what kind of asymptotes?
Slanted?
Slant. I love it. So slant asymptote here because it's higher power on the top than the bottom, both of these. So it's going to go to infinity, but it's going to go to infinity in a prescribed way. Oh, so does everybody get that shortcut that I just used here? I mean, instead of multiplying all this shit out, all I care about is what's the highest power of x I would get. Wouldn't I get an x squared from these two? Plus other shit. And then times another x is x cubed. And then here I get an x squared times another x is x cubed. So I really just have to look at these x's and any powers. Because all I care about is what is the highest power term. That's all I care about. What's really nice about these two is it's already factored. I already know where all the vertical asymptotes are and my x-intercepts are. That's beautiful. So why unfactor it if you don't really need to? Does that make sense? So on these, the main thing I've got to know for the horizontal asymptote is what is the relationship between the degree of the top and the degree of the bottom. When it's in this form, it's not as easy to see, but x cubed, x squared, x cubed. So it's both x cubed. That's the situation I'm in. It's multiplying the most important parts. So I don't care about all the other powers of x I get. I just care about the largest powers of x. So if I had something that looked like this, What degree would that be?
The fourth.
Yeah, x squared times x is x cubed times x is x to the fourth. I don't care about the 3. I don't give a shit about anything else. I just need the highest power because that's what degree is based on, is the highest power. Please let that make sense, because I really don't want you wasting time multiplying that shit out, because I normally not waste, but most of my time is focused on factoring these damn things. And this problem was nice enough to be factor of it. I don't want to mess with that shit. Is that all right? Yes. So when I'm talking about horizontal asymptotes, that's why I can focus my attention on the highest degree, because it's just the relationship between, like you said, the degree of the top and the degree of the bottom, which is the highest degree term. Okay. So coming back, is there any that, and this is the only other one that I can see, yeah, that has a situation. What would this horizontal asymptote be for this one? If the bottom degree is higher than the top, then as x gets big, it's going to go to
0.
Thank you. Right, so you have to know those 3 situations, and I've got that handout up on Canvas that actually, I'll show you it in a minute if you haven't looked at it, that kind of goes through each of the 3 situations. Higher degree on the bottom, 0. Equal degrees, ratio of coefficients. Higher degree on the top, slant. Okay, I think I'm going to not do any more in this and wait for more people to get to that homework so I can get some more specific questions. I'm going to clear all of this insane stuff. So anybody still need it up there? It's going away. Bye, chicken scratch. Okay. All right. So I want to show you how 5-7 is all stuff we've done already, which is always nice. No, we haven't talked about a mound of gravel, but their only point in this first little problem they do is to show you where cubic stuff come in naturally. So now this is really interesting. All right, I'm sorry. I'm going to have to go off in a little bit of a tangent here. Does that formula look familiar to anybody here?
Looks like a cone.
Yes. So the really, really crazy cool thing about a cone is it's a certain family of shape. It's actually the most basic pyramid, believe it or not. A pyramid officially in mathematics means that every point on the corners, and a circle is basically nothing but corners. It's one way to think of it. Every point is a corner. They all have to go to a single point on the opposing side. So that's a cone. Pretend like that's true. And the neat thing is, whenever I create a pyramid out of a shape, I cut away 2/3 of it, so I'm left with 1/3 of it. So see how this part is the cylinder? And 1/3 of that is the pyramid I would get in the middle, the cone. I know, this is weird to call this a pyramid, but. So here, let me see if I can do this. I'm going to really push my luck here today with my drawing ability. I have no idea what I've done so far that makes me think that I can do this. But I'm still going to try. So if I take every corner and take it to a single point on that side was a little bit wobbly. Can you guys see in the middle that's a pyramid? That's not my best. Oh well, screw it. I should have done a different color. All right, I'm going to stop. I tried. It's a little bit curvy pyramid. It was a more progressive group of Egyptians. Yeah, thanks. You don't have to butter me up. That's shit. That's fine. I can take it. All right, let me clear this. So again, the only reason they wanted to do this, and by the way, where did they get this? Because it actually says up here, sorry, it says the height is twice the radius. And then they can solve for the radius. And of course, what happens is you get a radical. So one big part of this section is obviously radical functions. That's kind of cool. I can just write everywhere. That's freaky. Okay, sorry. I should know that. I didn't. So I'm going to clear this. So there really isn't very much new. The one thing that's a little new, see here they have an inverse. We know how to find inverses, right? How do you find the inverse of a function?
Switch x and y and then solve for y.
Kick ass. And what's the one thing that you need to make sure about the function before you can do that?
It's
Like
restricted.
this. Yeah, I'm sorry, go ahead.
It's restricted.
Yeah, well, do you need to restrict it? So this guy doesn't pass the what test?
Horizontal line test.
Horizontal line test. So I would have to restrict his domain in order for him to have an inverse. So what's the most basic way I can restrict the domain and not cut too much away? Well, can I restrict the domain and chop some of this away so
From
that it can
0
pass?
to infinity.
Yeah, one way is 0 to infinity. What's another way?
0 to or negative infinity to 0.
Big ass. I like that because people often forget you don't have to cut him out. You can cut him out instead. I like it. Okay, so part of this section focuses on, can you determine how to cut the domain down, or even something like this. Oh shit, here comes the chat. Doesn't matter which one. No, so that's the thing. So in any problem, they either have to tell you what to cut out. If it's a real life problem, there should be real life restraints or constraints on the problem so you know what to cut out, right? But yeah, let me show you an example of a problem. It tells you what to do here. Let me see, let me get out of here. Blah, blah, blah. We already know the basics of inverses. So this is all going over the basics of inverses. Whoop-de-doo. Cubic is nice. Look at that. I love that shit. I still love the inverse graphing. Anyway, I'll stop. Looks like NASCAR lines. I love it. All right. Here we go. Restricting the domain. So here's an example right here. I love this example. It's the best example. I'm sorry. I'll stop. It's better than you can find in China. Do you see how they have a part A, part B? And this is basically related to those two different constraints that we just did earlier. The two domains, right? So why does it make sense that this might be one way? Because how would you graph this before I scroll down to where the answer is? What is the shift here? What's the shift?
To the right 4.
I like it. So never forget your transformations. They will come in handy. So it goes to the right 4. So then it basically looks like this. So I could either have x greater than or equal to 4 or less than or equal to 4, which is what that says. So the restrictions that they gave make sense. Now, real quick, you understand that I could do x greater than or equal to 5, right? And that does make it 1-to-1. Does that make sense? 4 is the one where I cut off the least I need to, which very often is what we try to find. I like it. I like it. So for part A, I know that my inputs have to be at least 4. Now listen. This is really cool. Let me do a little side example. If I know the domain of f is -7 to 8, do I know anything about inverse? Do I know anything about, just by me telling you this, and I'll tell you that that has an inverse. Do I know anything about the inverse function? Anything about it? You see, I love that question. It's so freaking vague. I love it. How do you find the inverse of a function? What do you do? You told me earlier. No trick questions. Come on. How do you find the inverse of a function?
Y and then solve for y.
Switch the x and y, right?
Mm-hmm.
So now take that to the largest sense. X is domain. Domain is the collection of all x's. Range is the collection of all y's. So the domain of f will become the what of the inverse? The domain of f becomes the what of f inverse. Oh, somebody's chat.
The range.
Yes. You gotta love that. You just gotta love that shit. You really gotta love that shit. It goes right along with X and Y switching. It's just the larger sense of that same idea. All right, so what does this have to do with shit? So, watch this. If I write this down, let me bring Y back. Let's go through the steps. So the steps are pretty easy. Now I start to solve. And what's going to happen when I start to solve? What do I have to do right here?
Plus or minus.
Good. Now we're going to resolve that in a minute because we know something. So then I got plus or minus. Get out of there. Let me write it. It's Y. I'm going to add the 4 over. Is that cool? Now, if my domain is 4 to infinity, then what's my range of this got to be? 4 to infinity. So which one do I check? Plus or minus for part A? My range has to be 4 to infinity. Does everybody get that? My domain for part A was 4 to infinity, so my range for the inverse better be 4 to infinity. So which one is it going to be, plus or minus?
Plus.
Plus, because that's going to make it 4 and then to infinity as x grows. Do you guys, that's so awesome. That is so beautiful. So of course, part B is just going to be y equals 4. Oh my God, what language am I using? 4 minus square root of x. Holy, okay, sorry. There's a little freaking button on my pen. Anyway, sorry, I'll stop. I don't know what it's for, but when I push it, it doesn't write. It sucks. Oh, I see now. I'm sorry. I am so sorry. Today has been such a long day. I am really sorry. I appreciate everybody's patience with me every time we meet. Okay. All right. I just found something out I didn't know. Okay. Does everybody get a feel for that? We have talked about this idea before. We just never got this specific about it. And I never got the chance to talk about domain and range switching. It's such a cool, that is going to come back to help us when we talk about trigonometric functions and inverse trigonometric functions and all that kind of stuff. This whole idea of domain and range switching for inverses is going to make things so much easier. Okay. Let me stop this. Let me clear all that away. I'm going to clear all my scratch items, all right? Clear. Okay, so beyond that, there's really not that much else in this section. It's kind of silly. We've done stuff like this before, I'm pretty sure. How do I find the domain of, oh, I'm sorry, this is just saying restrict the domain. This doesn't make any sense. So for this one, I see what they're saying. This is kind of going backwards because if I try to find this guy's inverse, it's going to be a parabola, which is a problem. So, I mean, this guy, again, the domain is going to be like that, right? It's going to start at 4. Is that cool? Because it's shifted to the right 4. So when I start to find this guy's inverse, let me just go ahead and do this. Square both sides, add the 4. I've got to restrict this guy's domain. But now let's see if you guys have learned this lesson now. This is going backwards from what we just did. Does everybody see the problem? I've got to restrict this guy's domain or else how can it be this guy's inverse when this guy has like 2 parts of him? Can't be. What's this? What do I need to know about this guy that will tell me this guy's domain?
His range.
His range, exactly, because the range becomes the domain when you do the inverse. So what is this guy's range?
Zero to infinity.
Good. So then what's this guy's domain got to be? It's trying to be a 0.
Zero
Good Lord.
to infinity.
Exactly. Zero. It's just that simple. It's the same idea, just in reverse. Okay, maybe. Maybe. There's a lot of cool shit happening right now. All right. I'm going to clear that away. It's not really a bad idea to give yourself a little visual of what you're working with, even if the problem doesn't ask you to. So then it's just easier when you have a visual anchor to kind of work off of. And consider this real quick. If I did just visually flip this over this line, shouldn't it be like this? Isn't that 0 to infinity as a domain for the inverse? Yeah, okay. So there's a lot of good things that can happen with a quick little rough sketch. Not a perfect graph. You don't have to do it in the calculator. You just need a quick little rough sketch. All right, let me clear all this. This is all going to go away. Bye. Okay. And I really don't think there's much else in here. Oh, look at this bad boy. Maybe there is. Look at him. So, oh my goodness. Well, this is sneaking in out of nowhere. All right. I don't know if you can tell that I really didn't prepare that much for tonight. I've had so much happening today. But this is such a cool problem. How the shit am I going to do this? So can somebody just, what is the idea of anything under a square root? Of anything under an even root? What's got to be true about the thing inside? What's got to be true about this?
It has to be 0 or greater.
I love it. So let me just start there. Now, this is the kind of problem. This is such a weird way for this book to sneak this in. This problem by itself is very interesting. Can somebody tell me, I really want this to make sense. Do you see, this is related to, how do I say this? Aren't these all multiplicity 1? What's another way to say greater than or equal to 0? What's another way to say that less mathematically, more with just words? It's got to be what kind of number?
Positive.
Positive. I'll accept it, but it should actually, now,
Natural.
you ready? Say again, sorry?
Natural is in natural.
No, that's going a little too far. It could be funky. It just has to be positive or 0, so a quick way to say that is non-negative. Non-negative is a quick way to say positive or 0. Okay. So what does that mean, Jeff? What does that mean? That means if I can figure out all the places that it's positive or 0, that's the answers. So there's a lot less work here to do than this makes it look like you got a lot of work to do. I don't know if you guys, does that feel like you got a lot of work to do? This is all I got to do. Where's this thing 0? What values is this thing 0?
-2 and 3.
-2. Can I count? I don't know. -1, 0. Just do it here, Jeff. It's fine. There you go. And 3. So I don't know why I'm putting a dot there. So here's what I do. I put a little z over those. Because it's 0. Where is it undefined?
1.
1. So what am I gonna put up there? I don't know. Like a U. Okay, now. So 1 would never be a part of the answer, obviously, no matter what. But these could be, and in fact, in this specific problem, they will be a part of the answer because it's allowed to equal 0. Stay with me. I don't know. Has anybody seen this before? So this type of analysis is actually going to happen a decent amount here, but like a shitload in calculus, if anybody's going to go to calculus. So here's what I do. The only place that this function can change signs is either at a 0 or around an undefined. And just to remind you guys, an undefined can look like this, right? An undefined can look like this. Do you see how it changed signs around the undefined? Okay, maybe. So I've got 1, 2, 3, 4 regions. And this is so kick-ass. All right, so here's what I do. Let me plug 4 in. If I plug 4 in, do I get positive or negative? That's all I care about. I don't care about the number. Positive times positive over positive, so it's positive. Does everybody? I don't care what the number is. I just care if it's positive or negative. Do I have to test anything else out here? No, it's always going to be positive forever Because there's no other zeros for it to cross through, and there's no other undefineds for it to be freaky around. Now, let me, all right. If I plug a 2 in, that's positive times negative over positive, so that's negative in there. Is everybody, I did that a little fast, is that all right? Plug a 2 in, positive, negative, positive, so it's negative. I'm going to show you a shortcut here in a minute. Then I plug a 0 in, positive, negative, negative, that's positive. And then I plug a -3 in, negative, negative, negative is negative. Now here's the shortcut. Everything in here has a multiplicity of 1, right? So all I needed to do was to know one thing, and then it changes sign, changes sign, changes sign. It goes through, goes through, goes through, because they're all multiplicity 1. Even around the undefined. Because on one side of 1, this is positive. On the other side of 1, that's negative. All right, so what's the answer then? Wherever this is positive or 0. So what's the answer? Where does it become positive or 0? What's happening? Nobody? On what region is this positive or 0? So let me help you out. So one region would be starting at -2 because it's 0, up to
1, but not
1. Not including 1 ever because it's undefined. You never include that freaky little dude. Or where else is it positive or 0?
3 to infinity.
Done. That is much less work than you would expect this problem to have. Because it's related to that magic 0. 0 gets so much shit, but 0 is so beautiful. If it's equal to 0 or inequality with respect to 0, that's the best that it could be. Because then I could make this problem into negative positive, which is a lot less specific work. How you guys doing out there? So you want to do another example like that? I don't know if you can tell. Yeah, we don't have much time left, so maybe we could do. Anybody care either way? Are you guys? Did everybody log in except for and then leave, except for the people with the camera? All right, I'm going to make the call. I'm not going to do another one. Too bad. All right. Don't want to interact with me. That's what you get. Oh, somebody's chatting at me. Too late now. Oh, well then let's do another one. All right. So what if I had this? Now, of course, this problem could start off unfactored, right? What, Jeff? I like it. I would. And let's say I want to know where this is less than 0. Less than 0. So since this is an inequality with relation to 0, I just have to make a number line and investigate the outputs of the function. What am I going to plot on that number line to get me started?
-4, -1, and +3?
Yeah, so at -1, so let me make myself a little scale. So I'm -4, -3, -2, -1, 0, 2, 3, 4. Okay. Shit, I forgot what it was. -4, -3, -2, 0, 1. I don't really trust myself tonight. All right. So at -4, it is, what am I going to put up here?
Undefined.
Undefined, I like it. And then at -1 and 3, I'm going to put 0, 0. Now watch. This is the only one that's got an even multiplicity, right? Even power. So what's it going to do around 3? Is it going to change sign around 3? No, because on one side of 3, this is positive. On the other side of 3, this is positive because it's freaking squared, right? So any even powers will make it stay the same sign around that number. So let's see, if I plug a 4 in, positive, 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 that's positive. And what I just say, what's going to happen on this side? I don't even have to plug shit in. Let's do the shortcut. What did I say about 3? It's going to do what on either side? It's going to, I really want you guys to get this. So you got to let me know if you don't get it. If I go ahead and plug something in, if I plug 2 in, positive, this is positive because it's squared. And that's positive. So since that's squared, it's going to stay the same sign on either side of 3. Now the other ones are to a first and a third power. So they're going to change signs around the numbers that make them 0. Because on one side it's negative, on the other side it's positive. That's all that is. That is all that is. So I know around -1 it's going to change signs. And I know around 4 is going to change signs. I don't have to put any shit in there at all. Can you? Yes. You can put a -2 in. Negative times positive over positive is negative. So you can still put shit in, but so now what's the answer? This is kind of, I didn't even really design this. This is kind of nice. This is a beautiful answer. What's the answer here? What's the only place it's negative?
Between -4 and -1.
Yeah, between -4, don't include that bad boy because he's weird, and -1. Not including him, sorry.
Yeah,
that last one.
because it turns positive.
Exactly, because it's not allowed to equal 0, but it can't include -1 either. So the last problem, we could include the zeros because the problem itself allowed equal to 0. Yeah, so the numbers that come from even factors, even power factors, it stays the same sign on either side. So if I just find one region, I can then say, okay, stay the same, change, change. Bam. I only have to input, even if there were a million factors, I would only have to do one thing and then change, stay the same, change, stay the same, stay the same, change, stay, and I got the whole damn thing done. Has anyone ever seen that before? I think nobody said they had. Does it make sense is the more important question right now.
Yes, it makes sense.
Okay. If it doesn't quite make sense yet, okay, that's right. It's the first time you're seeing it, so it takes a little while to get in the brain, but that's such a beautiful concept. In calculus, I'm not going to teach you calculus, don't worry. You're going to learn how to figure out the slope of any function. So when you do this thing, this would mean like it's going up, it's going down, it's going up, it's going up. So that's what the positive and negative would mean. And then you can get a lot more precise about sketching graphs by hand. You get more information. Okay. Enough of that. What time is it? Oh, well. It's be one night that we actually stay the whole time. Too bad. Okay. So I want to show you a little bit of where we're headed, because this next section should start off really nice. Should be basically your review. And so it's just exponential functions. And we've looked at this already. I'm pretty sure this was in one of the review sections with what's right here. What is this? What's special about y equals 0?
It's an asymptote.
It's an asymptote. I like it. I like it. So real quick, while I've got this up here, this is the last thing I say. And this is going beyond this section, but it's getting us ready for something coming very soon that's more interesting. If I wanted to graph, let me see if I can come out of here a little bit. Let me, will it? There we go. Okay. Oh, that's a little too much. Okay, go away. Okay, that's perfect. Okay. Real quick, real quick. If I were to plot this guy's inverse, how do I know there's an inverse?
Because it passes the horizontal line.
Passes the horizontal line test. What's going to happen to the asymptote? It's really easy. What happens when you do the inverse? What happens with the x and the y? You know what happens when you do the inverse.
Positive infinity.
I think I know what you mean, but what's the equation going to become? Right now it's y equals 0. So of course when I do the inverse, the equation is going to become, what happens when you do inverse? What changes?
X equals 0.
See, I mean, that's just almost too nice to believe. Everything about the damn thing, every x thing becomes the y thing. Every y thing becomes the x thing. It's almost too good to believe. So then it becomes here. And then if I just do a really quick rough, screw it. Well, I got points, don't I? So 1, 0, 2, 1, 4, 2, and then 1/2, -1. So it's going to pretend like it should be dotted. Screw it. So it's going to come up through here. It's going to go like that. So we know what the shape of this thing is. And just to kind of, this is going to be logarithms. In this case, it would be log base 2. So I don't know how much you guys have done logarithms. It's coming in a few sections because logarithms are the inverse of exponential. And that's, I think, enough. That's enough for tonight. I did a lot of weird shit today. I love it. Okay, so let me know if you have any questions, if you want to hang out for a little bit. Otherwise, you are free to go.
Thank you.
Anytime. Everybody's cool? I'm going to head out. I don't see any. I am out of here.